Hello everyone. Today we're going to cover power.
Down here.
What's going on?
Hold on there, just a minute.
I'll get some bolts, hang on. Dude, there's so many bulbs in here. 15 watts. 50 watts. 55 watt headlamp bulb. Not very much good, is it? 4.5 watts. Which one do you want?
We seem to have another electrical issue here.
What?
Let's just cut to the next presentation slide.
Here we go. So, what are watts? And what is power anyway? If you take this hairdryer for example, dries my hair nicely, and it says it's got a power of 2,100 watts. So what that means is the electrical energy that comes in is transferred into the heat and the kinetic energy that comes out the other end to dry your hair, and it does it fairly quickly. In fact, power is how quickly energy is transferred from one form to another. And we can work that out by power in watts is energy transferred divided by the time taken in seconds. So for this hairdryer, for example, we've got about 4,200 joules of energy going in, and it takes about 2 seconds to heat up to its maximum capacity. So 4,200 divided by 2, its power is 2,100 watts. Take your phone for example. Mine's dead. But anyway, if I was to charge it up, I plug it in to get the electrical energy, and it'll take about 45 minutes to transfer the electrical energy from the charger into my phone. So over that time, 45 minutes, is about 10,800 joules of energy that goes through this device. Over 45 minutes, that's about 2,700 seconds, divided by 2, the power of this charger is 4 watts. The Bugatti Veyron, first production car to get to 300 miles an hour, did that a couple of years ago. Now that transfers the energy from the fuel into kinetic energy. About 40 million joules of energy is converted over about 40 seconds it took them to get to that speed. So 40 million divided by 40, it's actually about 1 million watts of power, which is about 1,500 brake horsepower. Don't forget that when you're calculating power, it's always in watts. So if you see something written in kilowatts, so you have to multiply by 1,000. Take a couple of the finest technical runners of all time. We've got Florence Griffiths Joyner, over 100 metres. We're going to work out her power and compare that to Mo Farah, over 5,000 metres. So, Flojo converted all that food energy into kinetic energy, and it's about 3,000 joules of energy that's converted over 10 seconds. That works out to be 300 watts. And Mo Farah, on the other hand, not going quite as fast because he's got to run 5,000 metres. He converted about 1,600 joules of energy over just under 13 minutes, and that works out to be 2.5 watts of power for Mo Farah. Remember, Mo Farah's got to sustain that for 13 minutes or so. Flojo, a lot of power there, but it's difficult to even maintain that for 10 seconds. Don't worry guys, I'll do it.